Formulas for sums. In order to work out examples using summations to approximate areas, we'll need a few formulas. Here's a simple formula. It says the sum I equals 1 to n of c is equal to c times n. Imagine that n were 5. Sum I equals 1 to 5 of c would mean to add c to itself 5 times. c plus c plus c plus c plus c is 5 times c. In general, we get c times n. Here's another one. It says the sum I equals 1 to n of I is equal to n squared over 2 plus n over 2. Again, suppose n was 5. 1 plus 2 plus 3 plus 4 plus 5. We're saying that's equal to 5 squared over 2 plus 5 over 2. You can check it out and verify that it's true. Similarly, sum I equals 1 to n of I squared is this formula. These formulas are proved using a technique called mathematical induction. We're not going to do that here. But there's ways of getting these formulas for any polynomial. The patterns are not easy to recognize at all. We'll just use these in this video and in this calculus class. Let's look at an example of how we can use these to figure out sums that contain these terms. Here's an example. Suppose we want the sum I equals 1 to n of 3i squared plus 5i minus 2. In order to figure out that sum, we need to use each of these formulas, and to use those formulas, we need to break this apart. Since this is a sum, summation can be done in any order we like, so we can sum these things individually. In fact, we can sum up this first term, and since the 3 is multiplied by all of the I squareds, we can factor it out in front and say this is 3 times the sum I equals 1 to n of I squared. Plus, we can sum up the second term, and we can factor the 5 out, because again, we can factor multiplication out of addition. And then the last one is just sum I equals 1 to n of 2. So now we can start using these formulas. Here we see the sum I equals 1 to n of I squared, so n for that summation, we can replace it with this formula. So that becomes, this first term becomes this whole thing, 3 times this formula, n cubed over 3 plus n squared over 2 plus n over 6. Plus the second one, n for the sum I equals 1 to n of I, we put n squared over 2 plus n over 2. So it's plus 5 times n squared over 2 plus n over 2. And then for the minus sum I equals 1 to n of 2, well, 2 is just a constant. So we should just subtract, that's that minus sign, our formula, which is the constant times n, so it's 2 times n. So now you can work this out, distribute through the 3, distribute through the 5, work it all out, and we get a formula for this whole sum in terms of n. So no matter how big n is, n could be 1,000, n could be 1,000,000, all we have to do to sum this up is to plug n into this formula. So if n were 1,000, it would be 1,000 cubed plus 4 times 1,000 squared plus 1,000, and that would be this sum. Let's look at another example, which has a little bit of a wrinkle in it. This time we sum I equals 1 to n of I plus 1, but we divide by n. So the n occurs both as the number of things that we're summing out, but it also occurs inside the terms that we're summing. So this one is actually simpler than it looks because we can factor out the 1 over n. So that 1 over n can be written out front, and we can think of this as 1 over n times whatever this sum is. And we can split that sum up like we did over here as the sum I equals 1 to n of I plus the sum I equals 1 to n of 1. And now we can pull out these two formulas and figure out what each of these sums are. So the first sum is sum I equals 1 to n of I is n squared plus n over 2, or n squared over 2 plus n over 2. And the second sum I equals 1 to n of 1 is just 1 times n, so it's just plus n. And then we can simplify that just by simplifying the n squared over 2 plus n over 2 plus n over 2 plus n is 3n over 2, and then we just distribute through the n. N squared over n is just n, 3n over n is just 3, so we have n over 2 plus 3 over 2. That's a simple formula for this sum. We're going to use these formulas for sums in our approximation for areas, and we'll have problems like these.